Hey, Global Village. Okay, so I just watched a few YouTube videos that talked about the dead internet and how so much of the internet is now being filled up with ostensibly slop from AI. And specific, say, to YouTube, not even just talking about the content, but the simple fact of the matter that if someone decides to leave a message on your videos, there's a pretty reasonable chance it's just an AI bot doing it. And it may not be a bot that's saying something nasty, for example, in relationship to the genocide, but I think there are plenty of those going around. It could just as easily be a bot saying something generically nice, if only to try and create engagement. Um, I mean, I don't know what to say. I feel strangely alienated from YouTube at the moment. Not that I've ever particularly liked Alphabet or any of its subordinate companies. In fact, I quite intensely dislike them. Speaking of which, I got a unpleasant message pop up when I logged in a few days ago, telling me that one of my videos had just broken one of their rules, and I was going to get a warning this time, but the next time it happens, I'll be blocked from posting for a week. And if it happens again, then I'll have my channel removed. And then it was like, we don't want to lose you, but you have to follow these rules. And I thought, oh, here we go. Maybe it's something to do with the fact that I'm posting pro-Palestine content. But oddly, it was a very old video that I'd uploaded where I'd provided a tutorial as to how to upgrade your Nexus 7 Android device to a custom ROM. And this video was over 3 years old, and now it was complaining about one of the links that I supplied where you could go to actually download the custom ROM. Now, why it took 3 years for it to suddenly decide it didn't like that link, I can only speculate. It's possible maybe the link itself changed so that the content on it changed from when I originally posted it. I really don't know, but if that's the case, it seems incredibly unfair that I would actually get a warning for that. Simply because of the amount of time that's gone by would suggest that it's a little bit unreasonable to suddenly decide to complain about it now. I mean, sure, they can decide to disable the link, but to act as if I've committed some sort of violation is just really painful. I don't know. Everything about YouTube is just wrong, and so I did protest the warning I got, and I noticed that when I selected the protest, nowhere was I given an opportunity to explain why I'm protesting it. I just have to click a protest and it says we'll have another look at it. And I haven't heard anything more about it since, and to be honest, I don't really give a shit. But I don't know, it's weird. It is a bit suspicious that I suddenly got that error now that I have actually been posting this particular type of content. It just makes me wonder. But who knows? Anyway, bottom line is, internet really is going down the shitter. And I feel like, are there even any other humans out there anymore, or is it just AI bots that even engaging with my video? I don't know, man. Look, the reality is when I start creating these videos, I'm really just doing it as a kind of a historical archive. I have no expectation of actually creating an audience, despite the one or two messages that people have left, some of which may just be bots anyway. But anyway, related to that is why I've decided to create this video now, because I want to talk a little bit about AI. And the reason I want to do that is because I have actually I've been a software engineer my entire life, right up until the point where I guess my career got cut a little bit short due to my visual impairment. And I think I have a bit of an insight I would like to share. So primarily what I want to talk about is, why is it that an AI expert could make the following claim? They can say that they don't necessarily know exactly how the AI is doing what it is doing. Which, if you are a developer or if you're someone who's created anything, it's just very unusual for someone who's supposedly an expert in the field to then come back and say, well, we don't really understand how it's doing it. So, like, how could that be? Well, I can provide a bit of insight there, and I can do that by leveraging off the fact that, you know, I have been a developer for so long. So if you happen to be watching this and you have never been a developer, then this video might be of a little bit of use to you. Right, so let's first start with a traditional computer program, and I'm just going to pull a hypothetical out of my ass here and we'll just walk through it. So let's say you work for a very large company and you work in the software engineering department. Now, your manager comes up to you and he's got a worried look on his face and he says, I need you to write me a report. And what I want you to do is I want you to break down by department the total amount of salary that is paid to each department. And the reason I want you to do that is so that we can figure out which are the departments that we are spending the most salary on, so we can, you know, cut a few staff back and trim the fat, because the shareholders are complaining that we're no longer making enough profit to make them happy. They want bigger dividends, so we need to look where we can cut back. And your work colleagues look at you sideways because they realise that you've just been asked to perform a task that may result in people losing their jobs. But what are you going to do? You're a good little foot soldier, so you put your head down and you go ahead and write the program to produce this report. So what does this program look like? Well, let's suppose that you're going to read or use two file structures in order to do it. The first file structure is a file called departments, and in that file it has, say, the department name and, say, the manager of that department. And you're going to use another file which is called employees, which has obviously the name of the employee, but more importantly it has the salary of the employee and what department they work in. Right, so armed with those two files, you've probably got enough to actually produce the report. So the first thing you do is your program reads through the department file. And the reason you do that is you want to build an internal array in your program that lists all of the existing departments in the company. And in that array, you're going to have a subtotal, which will be the total salary for that department. And you'll be able to use that field to accumulate the summed value of the salaries of all the employees that are in that particular department. All right, so that's what the first thing your program does. So it's read through all that, all the departments, and it's built the array, and it's got the field allocated the fields for holding the salary. And then you go ahead and you read the employee file, and for each employee you just access their salary and you add it to the appropriate department total. And you just keep doing that until you've read the entire employee file. Excuse me. Okay, so now all you need to do is just produce the report, and that is simply a matter of displaying the department name and beside it the total summed salary for that department, and then you just print that out and you hand it over to your manager. And the manager looks at it and he goes tisk tisk tisk, and then he walks off and shows the CEO, and like a couple of weeks later you find you've got a letter on your desk, and you open it up and you find out that you are no longer working at the company, because it turns out the software engineering department was one of the most expensive departments in the company, so you've lost your job. along with a number of other people in the department, which, you know, reverse karma. I don't know, man. I don't know what you call that, but it's just what happens in the big city. Now, a couple of weeks later, when you're no longer working at the company, the accounts department comes to your old manager and says, we've noticed that there's something wrong with that report because we've just received the latest statement from the bank, and the figures on the statement don't seem to correlate with the figures that were actually in that report. So we think you need to go back and take a look at it. The manager then goes to one of the software developers who's still working for the company and asks them to check the program you wrote. So they go through it line by line. And the program, it just does all those things step by step that I talked about. And then what they discover right at the end, when it's actually printing out the report, is that it accidentally labeled the wrong department in 2 cases. So it called the software engineering department was actually the manufacturing department, and the manufacturing department was labeled the software engineering department. So for whatever reason, it titled them wrong because the developer's a dumbass and got that messed up. Right, so what happens? So the manager says, damn, I better go and fire a whole bunch of people from the manufacturing team, because that was actually the team that we were spending far too much salary on. And suppose we should try and get back a few of the software developers that we let go, though probably not you, the hypothetical you, because you were the one who put the bug in it in the first place, so you don't deserve to be re-employed. Brutal. One little mistake, and look what happened as a result. Okay, what did we learn from that? We learned that another developer was able to look at your program, walk through the code, and understand exactly how it worked and even what the problem was. So why is an AI program so different? Right, so we can actually talk a little bit about how these AI programs work. So there was this thing called machine learning, which just generically refers to the whole realm of computerized learning mechanisms. And then there was another thing that came along a little bit later called deep learning, which leveraged off neural networks, layered neural networks. And that was where things really took off. And, things like large language models, and all the sort of modern AI technologies that are being used right now are all using deep learning. So let's just talk a little bit about how this deep learning mechanism works, and then we can understand why these things tend to become a bit of a black box. Right, so first of all, we're going to create this hypothetical. We're going to say that we've got, we want to create a program that can accept images of just general pictures and then determine whether or not there's a picture of a cat embedded in it. So, all right. The first thing we probably want to do is we want to say that we're going to scale the image that we're reading in, so it's always a standard resolution. And for argument's sake, let's say it is scaled to 1,000 by 1,000 pixels. Which means that it's a total, each image has a sum total of 1,000,000 pixels that go to make it up in a 2-dimensional grid, X and Y. Great. Now, what we do with our neural network is that the first layer of the neural network will be a 1-to-1 mapping of each pixel. So the first layer will be 1,000,000 neurons. And what do these neurons do? Not a lot, but what they will do, probably, for argument's sake, is they will hold the color value of the pixel and, say, the brightness of the pixel. And we'll have that piece of information for all 1,000,000 of those pixels. And that will be, 1,000,000 neurons holding that piece of information. Now, that is obviously not enough, you would think, to be able to say, is this a picture of a cat? So we need more layers. So the next layer of neurons will reference back to the first layer, but it will have some slightly more abstracted information, such as do the adjacent pixels do what relationship do the adjacent pixels have? For example, are they of a similar color and brightness? If so, there might be a neuron to represent that. And let's say maybe we want a neuron that represents the fact that they are of similar color, but they're very different brightness. Or maybe they're of the different color and different brightness. So all sorts of neurons that just describe relationships between pixels. And this is your second layer. Now, the second layer may be substantially less than 1 million pixels, 1 million neurons, or it could be more. It really depends on the type of information that we're abstracting out, and there can be a one-to-many link up from the original neuron layer down to the second neuron layer. So, you know, you can imagine sort of lines that draw from one to many of the below neurons, depending on, it may be that the pixel information can successfully relate to 2 of the neurons below it, in which case there would be 2 lines that you would draw between them. Okay, now the third layer may be a little bit more abstract again. The third layer may say that we're going to now construct potentially geometric shapes if the neurons above actually describe what we think might be kind of a bit of a semicircle, or say a straight, mostly horizontal line, or perhaps a angular line, or a perfectly vertical line. And so we then can tie the neurons above down to the neurons below, depending on whether they then describe that sort of slight geometric shape. And then below, the next set of neurons below that could describe a slightly more complete geometric shape, right? And you just keep going until you feel like you've got the sort of necessary descriptive sort of a way to describe what, I don't know, we might be able to use to construct what could be a cat embedded within the picture. And this will be, potentially many layers of neurons to finally get to that point. And there's going to be all sorts of potential link-ups all over the way. So it's a very, very complicated, very busy-looking structure. It's just lines linking up to neurons, basically. And what do we do after we've got that? Well, the interesting thing about these neurons is that they also have what is called a weighting. Now, that weighting will, before the neural network has been trained, every weight will be at 50%, which means it's a completely neutral weighting. Now, what happens then is when we then start feeding pictures, training data into the neural network, these weightings can be transformed, and they can be transformed in the following way. So we put in a picture, and let's say that picture has an image of a cat in it. And the existing neural network interprets the image, and it sort of lights up or links up a whole bunch of neurons through the network all the way down to the bottom. And then at the bottom, then we then ask the question, is there a picture of a cat in this image? And the neural network will tell you, based on which neurons got lit up in that, whether it thinks there is a picture of a cat. Now, if it got it wrong, so like there was an image of the cat in there, but the neural network said there wasn't, then all of the neurons that fired to actually make that incorrect conclusion, the weightings will be weakened ever so slightly. And then you can just repeat the process by either putting in another random picture of a cat, and it just keeps going, and it's either going to get it right or it's going to get it wrong. And every time it gets it right, the neurons, the neuron pathways that led to that answer all get slightly strengthened, so the weights all just get slightly upgraded. And you just keep going with potentially hundreds of thousands, if not millions, of pictures of cats, and which I guess you would call positive reinforcement, because if you're always giving it images of cats, then that would be like, a positive image. But maybe you also want to feed in images where there are no cats, so you can make sure that it also will correctly figure out when a picture doesn't have images of cats, just to sort of work it in both directions. Anyway, you've processed through God knows how many images, and your neural network now just seems to always get it right. So at that point, you can now have a person out in the wilderness can take a picture of a cat and then can feed it into this network, and hey presto, it will just tell them there's a picture of a cat. Now, if you were to give this program to another developer and just say to them, what is this doing? And they'll look at it and they'll probably struggle mightily to even figure out that the purpose of the neural network is to decide whether or not there are cats in a picture. It will be really hard work for them to even just figure that out. But it would be even harder for them bordering on almost virtually impossible, for them to understand exactly how it is the neural network is figuring out that images that you put in actually are images of cats. Just based on looking at this like ocean of, I don't know, potentially millions of neurons with all of these linkages together with, abstract, with weightings sort of webbed through it like a spider web. This is going to be beyond the capacity of the human brain to be able to look at that and then just come up with a rationale as to how the hell it's actually doing that. Now, the example that I've given you is actually probably about very simple, on the spectrum of the sort of neural networks that are being used today, especially for these large language models. That's super simple. So it would be orders of magnitude even more complex and more abstract, the way it's somehow sort of associating our usage of language so that it can feed it back to us in interesting ways, such that we become convinced that it's actually knows what's going on and is having an intelligent and meaningful conversation with us. In truth, it's doing nothing of the kind. It's simply using these sort of pre-trained neurons based on the massive amounts of data that it's been processed to just figure out what is likely to be the correct answer to a given question and what is likely to be the wrong answer. Anyway, this is why we have got people in this day and age coming along and just making very sort of strange claims about these networks, because we just don't completely understand how the hell it's doing it, other than, we can create these nested neurons, I guess, with a basic conceptual idea of how they can all link together to produce an answer. And then we just throw mountains of training data at it, and hopefully it all comes together and just works. And so there's probably even a little bit of experiment in there. They've probably gone back to the drawing board a few times, created new types of relationships and layers of neurons, until all of a sudden they start getting really positive outputs and results. But maybe they don't even completely understand why it works so well. So there's a kind of a bit of black art there. The weird thing is, like some people are starting to act as if these large language models based on these deep learning techniques are sentient, that they're in some sense alive. And I think this is just a classic example of how humans just anthropomorphize everything. We've always done it. We've done it long before there was ever AI. Like how dudes like to call their cars, a woman. They give their car a female name potentially. Call it Sally or something like that. Or how I don't know. We might decide that a particular piece of pottery that we like, we give it a name. And we call that's Bill. Humans just do that shit all the time. And of course our pets, we sort of turn our pets and attribute to them human attributes, It's just what we do, and so it's no surprise at all that we're now doing that with AI technologies that are made to mimic human behaviour. Yeah, so clearly I'm not of the opinion that these new software tools are somehow a model of the human brain. I just don't believe it. I think there's a lot more going on inside our heads that we just don't yet understand. Now, does that ultimately mean that we can't create some sort of arguably sentient and then maybe even conscious artificial mind? Possibly. Who knows? But personally, I think we are still a very, very long way away from that. And I think there are some qualitative breakthroughs that we need to make, which we have not made yet. And I think just creating ever more complex neural networks based on this deep learning system is not the qualitative. That's just a quantitative process, really. We can just keep pushing the existing technology quantitatively, but I think there needs to be a further qualitative breakthrough, and possibly more than one. So who knows? I do find the whole philosophy of mind very interesting, and I have written a science fiction novel, which I'm quite proud of, and which one day I may release right here on YouTube for anyone who's interested in checking it out. Where I kind of explore the whole idea of a conscious machine mind and whether such a thing could ever exist. Anyway, I think that's all I've got to say about this. I don't know why I wanted to create this video. I just did, It's just part of being human and wanting to talk about shit that I find interesting. In a world that I think is becoming increasingly dystopian, especially with the way AI is starting to take over the internet, and we've got this whole enshittification thing going on. I'm certainly old enough to remember when the internet felt a lot more exciting and a lot full of promise and a bright, fantastic future full of possibility. But right now, it just feels like it's been taken over by large corporations, and there's just very little in the way of true opportunity or creativity left. So, yeah, it's a pretty bleak way to end, isn't it? Anyway, Bendy out.